An elastic collision is an object that violently strikes and bounces off another object, thus conserving both kinetic energy and momentum. Let's take a look at elastic collision. First thing is we're looking for a collision. So you can see two objects here, a black block and a blue block of equal mass. In the first case, the objects are coming towards each other in a head-on collision. And in the bottom case, the two objects are going in the same direction, except the blue block is traveling at a slower speed compared to the black block. Both the blocks collide into one another when they touch. So that's our collision. The next part you need to see is where they are elastic in nature. Elastic means that they're going to bounce off of one another. In both cases, you see the collision is elastic, where the two blocks bounce off of each other. Let's take a look at the bounce more closely. The bounce occurs somewhere right around here. To the left of the bounce is before the collision, and to the right of the bounce is after the collision. So let's take a look at that bounce. A bounce tells us that both kinetic energy and momentum are conserved. Both kinetic energy and momentum involve two parameters. They involve mass and they involve speed. Conservation of kinetic energy and conservation of momentum on a bounce tells us that both mass and speed are conserved. And what that means is the total mass before the collision and the total speed before the collision is the same as the total mass after the collision and the total speed after the collision. Let's take a look at the first case collision. Before the collision, we see two blocks, a black block and a blue block. After the collision, we see the exact same two blocks, a black block and a blue block. No more mass has been added and no more mass has been lost. So the amount of mass before the collision and after the collision is the same. So we say the bounce tells us that both kinetic energy and momentum are conserved, or mass is conserved and speed is conserved. So if you take a look at before the collision, we have a v and a v over 2. And then after the collision, we also have a v and a v over 2. The total amount before, a v plus a v over 2, is the same as the total amount after the collision, which is v plus v over 2. The total amount of speed before and after the collision is the same because of the bounce. And therefore, we have kinetic energy and momentum conserved in this elastic collision, which is an object that violently strikes and bounces off another object.